Hello, we are here for one more lesson of this AxisVM training course, and the topic for today will be the vibration analysis. To show you what we can do with this type of analysis, I've opened this model. It's just an example to allow us to enter in the dialog boxes where we can see the different options of analysis. In these tabs, we want to check about vibration. So I've entered here, so we are seeing what is available for the vibrations. And inside vibrations, we have two different dialog boxes with options. This first one, which open this interface. And to start, it is important to apply a definition of what we can achieve with the vibration. So with this type of analysis, we can determine the lowest natural frequencies and mode shapes that correspond to the free vibration of an undamped linear structure. There are, as I said, a lot of options, and we can see them here. So starting with what we can define. So first parameters that we can choose, it is this first order or second order vibration. And starting with the first order, this is a solution that does not include the effect of the axial forces of trusses and beam elements on the system stiffness. On the other hand, the second order, it will include this effect on these elements. Then we have the number of mode cases. And in here we can select the number of mode cases of the vibration mode shapes, and we have a maximum established that it is 99. We have a default value of 6, but we can define other values. In this area here, we can select a case, and the loads are converted into masses. If a second order analysis is selected, the results of a linear static analysis or first order precedes the vibration analysis. Then we have also a couple of options here in this area, where we can choose this option called convert loads to masses. And enabling this conversion, we will make this application to convert the loads into masses. Instead, we can choose the masses only, where we can analyze the models without the loads, but with masses. Then we can go to convergence criteria, where we can determine two things called the eigenvalues and the eigenvectors if they have the required accuracy. And it is important that we can establish these tolerances properly to achieve also precise results. We can define the maximum number of iterations. This is the maximum number of results that the system will look for. And for both of these things, the eigenvalue and the eigenvector, we can define the tolerances that are applied to these iterations. Then the diaphragm, it is applied when we are running a vibration analysis with this option. The slabs are converted to diaphragms, and also all slabs, or what we can call horizontal plates, will be replaced by this type of elements. The purpose of this choice is to reduce the complexity of the model, and as a result it will have a lower running time to execute the calculation. About this, the stiffness reduction, we have explanations in other chapters previously talked about in these lessons. And we can also use here the increase support stiffness when we can increase this value as supports act in different ways during vibration. So we can deal a little about this parameter to have different results and to obtain more realistic vibration results. Then going to masses, we can include the mass components on the ones you check. So if you check one of these fields, they will be used in the calculation, and they are useful when we are calculating modal masses on the directions that we choose here. Another option for mass matrix type, this we have two options, diagonal and consistent. The diagonal is a lower or less complex version of this type of matrix, and the consistent, it is the complete mass matrix with centrifugal inertias. In here we can have the masses taken into account, all masses, or above height z, where you can define a certain height. Then for the vibrations in second order, we have the exact same calculations. So the only difference is what we explain when we start this video, where for first order it was not included the effects of the axial forces, but besides that it is the same. Still under vibrations we have another dialog box with options, and this dialog box, it is what we call the vibration response factor, where we have a couple more situations to check. And the idea to have this specific dialog box has to do with what is happening now, where we have more efficient designs and where we use stronger materials that lead at the same way with lighter structures. The problem it is that the vibrations that are human induced on floors, it is increasing, and we can cause in terms of vibrations uncomfortable or unacceptable phenomena for other people on the buildings, or that make delicate operations impossible, like in precision laboratories, in theaters, whatever. Okay, so this specific dialog box allow us to define parameters and settings to have all these phenomena into account for the calculations. So first, this area vibration results to use. So we can choose from load cases or combinations what we want to use to make this analysis. Then we can have the model shapes to use, where you can choose from all model shapes or shapes activated in the table. And we can define also these settings below a frequency limit, where we can define which one it is. Then we have the excitation method, and we have three different methods available. Each one creates an R result component, and we have this full excitation at the extremes or excitation at the node where we are making the analysis. So you can read a little more about it in our theoretical part. We have also a damping ratio that we can use to have it in account of in the calculation. And regarding footfall, I would suggest you, even that we can talk a little about this. We have a specific guide for this module, FFA guide, where you have a couple of explanations about the algorithms that are used and some design methods. But anyway, we can have these chosen from a different design method, and we have two. Again, if you want to see what each one of those does, read a little about that particular guide. But then we can have take in consideration this topic here, number of steps, the length of the walking path, and the mass of the walker or the people. And we have also parameters for frequency of pace in slabs and stairs. So it is quite interesting and very complete to have all of these things that can cause this vibration phenomenon taken into account in this type of analysis. My suggestion it is also to check our videos, because we have a couple of examples showing, if not all, some of these phenomena and some of these parameters, and for sure it will help you also a little seeing what it happens and how to deal with all these definitions for your work. Any help, any support that you may need, we are here to give you all the help if you make us and send us some comments or questions.